Hello everyone, my name is Anur. In this video, I'm going to show you design of G+3 building to Eurocode or Ethiopian standard in ETABS. Okay, ዛሬ ደግሞ ETABS ውስጥ G+3 የሆነ ህንጻ which is reinforced with concrete structure ETABS ውስጥ እንዴት ዲዛይን እንደምናደርግ step by step አሳያችኋለሁ ማለት ነው። Okay, as you can see, this is the architectural drawing of the structure. So the whole structure ETABS ውስጥ በቀላሉ እንዴት ዲዛይን ማድረግ እንደምንችል አሳያችኋለሁ ማለት ነው። Okay, therefore before directly going to ETABS, first it's important to know some important data that help us to design this structure. Okay, ስለዚህ እነዚህ ዳታዎች በደንብ ቀድመን ማወቅ ይኖርብናል ማለት ነው ቀጥታ ስትራክቸሩን ዲዛይን ከማድረግ። Okay, መጀመሪያ ምንድነው እነዚህ important ዳታዎች ማወቅ ግድ ይለናል ማለት ነው። Okay, ምንድነው function of the structure? This structure is student assistance building. ስለዚህ ተማሪዎች ለተለያየ ሰርቪስ የሚጠቀሙበት ህንጻ ነው ማለት ነው። Therefore, location of the structure is in Ethiopia, Addis Ababa. Okay, ስለዚህ function of the structure ማወቅ ምንድነው ካቴጎሪ ክላሲፋይ አድርገን ላይቭ ሎድ ከዩሮኮድ ወይም ደግሞ ከኢትዮጵያን ኮድ ስታንዳርድ ላይቭ ሎድ ለመውሰድ ወይም ደግሞ ለመጠቀም ይጠቅመናል ማለት ነው። Location of the structure is in Ethiopia. Ethiopia መሆኑ ሎኬሽኑ ምንድነው ጥቅሙ ወይም ደግሞ what is the importance of knowing the location of the structure? This classification is important because we can easily understand in which zone the structure is found. Okay, therefore seismic zone ካወቅን simply we can take the peak ground acceleration. Okay, in our case the structure is located in seismic zone. Therefore, for seismic zone in Ethiopian building code standard, peak ground acceleration is 0.1 g. Okay, soil type B. This data comes from the geotechnical investigation. Therefore, bearing capacity of soil 300 kilonewton per meter square. ይሄ ሁሉ ጥቅሙ ምንድነው? Just for designing the foundation. Okay, well, type B ያልነው እዚህ ጋር ደግሞ earthquake ወይም ደግሞ seismic analysis ለመስራት የሚጠቅመን ፓርት ነው ማለት ነው። Well, concrete strength is used for column, beam and slab. C25 30 ይሄ already የምታውቁት ነው concrete strength ለምን እንደሚጠቅም። Steel characteristic strength S450. Diameter of the longitudinal bar is 16 mm. Diameter of the transverse bar is 8 mm. Concrete clear cover 25 mm. Concrete cover to longitudinal bar center 41 mm ነው። Therefore, dimension of the column is 400 by 400. እነዚህ preliminary dimension ናቸው. According to our design, we can ይሄ መቀነስ እንችላለን. We can increase or decrease. Okay, the size. ሌላ dimension of the typical beam, which means floor beam ላይ ያሉ ማለት ነው 300 by 400. Dimension of the grid beam 200 by 300, which means 200 width, 300 depth. Okay, thickness of the slab is 150 mm. This calculated from deflection requirement. Live load in the classification ስለዚህ 4 kilonewton per meter square ተጠቅመናል። Wall load or the partition load that rests on the beam, which means line load 10 kilonewton per meter. Okay, partition load, which means area load, equals to 1.5 kilonewton per meter square. Okay, we have to know the difference between the line load and area load. ስለዚህ ላይን ሎድ ማለት ቢም ላይ እንደ ላይን ሆኖ አክት የሚያደርግ ኪሎሜትር ፐር ሜትር ነው። ኤሪያል ስንል ደግሞ በአንድ ኤሪያ ውስጥ የሚኖር ሎድ በሜትር ስኩዌር በአንድ ሜትር ስኩዌር ውስጥ የሚኖር ማለት ነው። ኦኬ, therefore this partition load is ስለዚህ በፓኔል ውስጥ ያለ partition load practically እንደምታዩት ወይም ደግሞ አርኪቴክቸራል እንደምናየው from panel to panel the partition load is different. Okay, ይለያያል። ነገር ግን እዚህ ጋር for the illustration purpose ስለሆነ ይሄ tutorial we have assumed that all the panels or the rooms have the same partition load, which is 1.5 kilonewton per meter square. Okay, floor finish this is also area load 2 kilonewton per meter square. Okay, ይሄ እናንተ ራሳችሁ ካልኩሌት ማድረግ ትችላላችሁ። next ከዚህ ሌላ ኢምፖርታንት ዳታ ምንድነው? የአርኪቴክቸራል ፍሎር ፕላን ኤሊቬሽን ሴክሽን በደንብ ማየት መቻል አለብን ማለት ነው። ኦኬ፣ ስለዚህ ለጊዜው ምንድነው ፕላኑ ብቻ ነው የምናየው ማለት ነው። therefore the ground floor plan ይሄ ይመስላል። ኦኬ፣ therefore እዚህ ጋር እንደምታዩት አርኪቴክቸራሉ በደንብ አይታይም ፒዲኤፍ ስለሆነ ማለት ነው ነገር ግን እዚህ ጋር እንትን አድርጌዋለሁ እንደ አዲስ ሪድሮ አድርጌዋለሁ ምንድነው ኢምፖርታንት ነገር እዚህ ጋር የሚጠቅመን የግሪድ ስፔሲንግ እና ናምበር ኦፍ ግሪድ ክላሲፋይ ለማድረግ ነው ኦኬ እንደምታዩት here በx direction if this is x direction and this is y direction a b c d e ያለ እስከ h ግሪድ አለ ኦኬ ስለዚህ በy directionም 1 2 3 ያለ ከፍሎታል ኦኬ this is important however አንዳንድ ጊዜ ካንቲሊቨር አለ እዚህ ጋር እንደምታዩት ኦኬ እዚህ ጋር ደግሞ ስላብ አለ ስለዚህ የነዚህ ግሪድ ማወቅ አለብን ለምንድነው ግሪድ ካስቀመጥን ሲምፕሊ ቢሙና ስላብ ድሮ ማድረግ እንችላለን ኦኬ ሳንሳሳት ማለት ነው therefore ይሄ ግሪድ አርኪቴክቸራሊ ዲፎልት ያለ ግሪድ ምን ማድረግ አለብኝ ማለት ነው ኤዲት ማድረግ አለብኝ ኦኬ for example here እንደምታዩት እቺ ካንቲሊቨር 1.2 ወይም ደግሞ 120 ሴንቲሜትር ወጣለች ኦኬ therefore 1.2 ከሆነ ከፌስ ኦፍ ዘ ኮለም ነው from the center of the column 0.2 ሲጨምሩበት 1.4 ይሆናል ይሄ 1.4 ሌንግዝ መካተት አለበት ኦኬ ምክንያቱም ይሄ ቢም ለመሳል ማለት ነው ኦኬ therefore ከዚህ ጋር መጀመር አለብኝ a ብዬ የa ቫልዩ ደግሞ ወደ b እያልኩኝ መሳል አለብኝ therefore እዚህ ጋር እንደምታዩት ግሪድ ስፔሲንጉ በx ዳይሬክሽን 1.4 ከዛ 3.5 ከዛ 2 ይሄ 3.5 ያለው የትኛ ነው ይሄ ነው ማለት ነው this length okay up to this ከዛ 2 ሜትር የ2 ሜትር ያለው ደግሞ ይሄን አካባቢ ማለት ነው በዚህ አርጉ ከዚህ ወደዚህ የምትሄድ ማለት ነው ኦኬ እያለ ይቀጥላል generally ስንት ስፔሲንግ አለ ማለት ነው በኤክስ ዳይሬክሽን 1 2 3 4 5 6 7 8 9 10 ኦኬ በዋይ ዳይሬክሽንም the same ካንቲሊቨር ካለ ካንቲሊቨሩም ማንኛውም ነገር ኢንክሉድ ለማድረግ ግሪድ በትክክል መከፋፈል አለብን 0.5 0.8 5 1.945 5.5 1 እያለ ይሄዳል ማለት ነው ኦኬ እንግዲህ ቲፒካል ስቶሪ ሄይት ደግሞ 3.23 ነው ፋውንዴሽን ኮለም ወይም ደግሞ ስቶሪ height of the foundation 2 meter ነው ኦኬ well ሌላ ደግሞ first and second floor ነው first and second floor typical ናቸው they are the same therefore grading systemum አንድ አይነት ነው ስለዚህ ቀደም እዚህ ጋር እንደምታዩት የy direction እነዚህን ካንቲሊቨር ኢንክሉድ ለማድረግ ነው ኦኬ ይሄ ካንቲሊቨር እንደምታዩት ቶታሊ this cantilever 1.3 ነው ኦኬ ዲስታንሱ ስለዚህ ይሄ 1.3 ግሪድ ለማጠቃለል ይሄ 1.3 ነው ሌላ ደግሞ እዚህ ጋር የሚገባ here we have small cantilever okay balconies this length is 0.5 ናቸው okay 0.8 ናቸው ይሄ 0.8 ነው ይሄ ደግሞ 1.3 ነው ስለዚህ ይሄ ዲስታንስ እንት ነው ማለት ነው 0.5 ስለዚህ from this to this 0.5 from this to this 0.8 from this to this 5 from this to this 1.945 from this to this 5.5 from this to this 1 meter okay this is the grid ስለዚህ 0.5 0.8 5 1.945 5.5 1 0 ስለዚህ number of grid in y direction 6 ይሆናል ማለት ነው 1 2 3 4 5 6 okay ይሄ ደግሞ third floor ነው እንግዲህ the same ነው third floor ከሰከንድ እና ፈርስት የሚለያየው ምንድነው እዚህ ጋር ካንቲሊቨሮች ዲስአፒር ሆነዋል የሉም ማለት ነው ኦኬ ስለዚህ ይሄ እናንተ ስራ ይሆናል ማለት ነው አርኪቴክቸራሉ በደንብ ማየት ይኖርባቸዋል ማለት ነው ኤሊቬሽን ሳይድ ፍሮንት ቪዎች እንዲሁም ሴክሽን በደንብ መታየት አለበት ማለት ነው ኤቭሪቲንግ ኢንክሉድ ለማድረግ well roof plan የመጨረሻ እንደምታዩት this is the roof plan okay እዚህ roof plan ላይ ምንድነው መጨረሻ ላይ የተጠቀሙት ሩፍ ቆርቆሮ ነው ስለዚህ ኢጋሺት ሩፊንግ አለ ከዛ ትረሱ ደግሞ rectangular hollow section ነው እንደምታዩት ፐርሊን በ1 ሜትር ስፔሲንግ ተቀምጧል ስቲል ደግሞ ኦሬዲ በአርኪቴክቸራሉ መሰረት እዚህ ጋር ሞኖ ፒች ነው መሃል አካባቢ ደግሞ ዱ ፒች ነው እዚህ ጋር ደግሞ ሞኖ ፒች ነው ኦኬ እንደምታዩት ይሄ የሚፈሰው ተፋሰሱ ወደዚህ ነው ኦኬ this is to this side and this to this side okay therefore here we have one truss which means dual pitch truss ጫፍ ላይ ደግሞ እዚህ ጋር ደግሞ ወደዚህ የሚፈሰው ሞኖ ፒች truss ይኖራል እዚህ ጋር ደግሞ ሞኖ ፒች truss ይኖራል okay in this tutorial we are not going to model this truss with the structure model አናደርገውም but it is important to model it ነገር ግን እዚህ ዝም ብለን ሞዴል ሳናደርግ the reaction ከትረስ የሚመጣ ሪአክሽኖችን ወደ ስትራክቸሩ አፕላይ እናደርጋለን ማለት ነው። therefore እዚህ ጋር ምንም ማወቁ አሪፍ ነው፣ ነገር ግን ሞዴል አናደርገውም። ሌላ ጊዜ ከፈለጋችሁ ግን ሞዴል ማድረግ እንችላለን ማለት ነው። አብረን ትረሱ ከስትራክቸር ጋር ሞዴል እንዴት እናደርግ እናያለን ማለት ነው። ኦኬ now let us go to ETABS። ኦኬ ወደ ETABS እንሂድ። go to ETABS። ኦኬ here already ነው ከፍቼዋለሁ። go to file new model። ኦኬ use built in setting with የሚል አለ። ኦኬ ስለዚህ እዚህ ጋር እንደምታዩት ያስመርጣችኋል። ዲስፕሌይ ዩኒት በማን ይሆን እያለ ነው። እናንተ ደስ ያላችሁ መጠቀም ትችላላችሁ። የስ ከስተመር ያለ ሜትሪክ ኤምኬኤስ አለ፣ ሜትሪክ ኤስ አለ። ይሄ ነው የምጠቀመው ማለት ነው። ኦኬ therefore still section database euro ተጠቅሜያለሁ። እናንተ ደስ ያላችሁ መጠቀም ትችላላችሁ። still design code Eurocode 3 እዚህ ጋር still አንሰራም፣ ነገር ግን ከፈለጋችሁ ትረስ ምናምን ሞዴል አብራችሁ ካደረጋችሁት ይሄም ሰሌክት ማድረግ አለባችሁ የፈለጋችሁት ኮድ መሰረት ማለት ነው። ኮንክሪት ዲዛይን ኮድ Eurocode 2 ብየዋለሁ ማለት ነው። ኦኬ እንደምታዩት የግሪድ ዳይሜንሽን በፕላን እና በስቶሪ ዳይሜንሽን ሰጥቶናል። በዚህ እንጀምር። ለምሳሌ ዩኒፎርም ግሪድ ሲስተም ነው እዚህ ጋር የሚሰጠን፣ በኋላ ነው we can edit okay by ourselves። okay what are the number of grid line in x direction? okay previously አይተነዋል። this is 10. okay number of grid in y direction 6. okay spacing of grid in x direction ይሄ እንግዲህ ኤዲት የሚደረግ ነው። it's not uniform ባለበት እንተው። okay story height bottom story height 2.5 ነው የእንትኑ፣ የቲፒካሉ ደግሞ 3.23. okay number of story ከእንትን ስለሚያደርግልን 4 እንለዋለን ይሄ ማለት ነው። ኦኬ ኦኬ ናው እንደምታዩት ይሄ እንግዲህ ዩኒፎርም ግሪድ ሲስተም ነው። እኛ ምን ማድረግ አለብን? ኤዲት ማድረግ አለብን። ራይት ክሊክ አድ ሞዲፋይ ግሪድ የሚል አለ። ኦኬ እዚህ ጋር ትመጣላችሁ። መጀመሪያ ስቶሪ ዳታ ቼክ እናድርገው። ኦኬ ቤዝ ላይ 0 ብሎታል። እኔ ግን የምፈልገው ምንድነው ሄር እዚህ ጋር ኔጌቲቭ 2.5 ኦኬ እዚህ ጋር 2.5 ስለው ስቶሪ 1 ኤዲት አድርጉት፣ ግራውንድ በሉት፣ ግራውንድ ፍሎር ፈርስት ፍሎር second floor third floor ኦኬ እንግዲህ እዚህ ጋር ሩፍ ይቀራል ማለት ነው። ስለዚህ ምን እናደርጋለን? ራይት ክሊክ አድ ስቶሪ ኪፕ ስቶሪ height እዚህ ጋር 3.23 number of added story and insert above third story from existing third story ኦኬ ስለዚህ ይሄ ሩፍ እንለዋለን ማለት ነው። ሩፍ ስለዚህ make sure that elevation finally 12.92 መምጣት አለበት ማለት ነው። ኦኬ የአርኪቴክቸራል የሚያሳየን እንደዚህ ነው። ኦኬ ስለዚህ ኦኬ ብለን እንወጣለን። let us edit grid systems ኦኬ እዚች ጋር modify show grid system ይላል። ክሊክ እዚህ ጋር display grid data as ordinates የሚል አለ። let us take this display grid data as spacing ኦኬ ለኔ የሚቀለኝ ስለሆነ ነው። እናንተ በኦርዲኔት መጠቀም ትችላላችሁ። ኦኬ now let us insert the values of spacing a ስንት ነበረ ቼክ እናድርገው እስኪ። እንደምታዩት x በx ዳይሬክሽን 1.4 3.5 2 5 4.5 ኦኬ እያለ ይቀጥላል። ኦኬ 1.4 5 4.5 4.5, 3, 3.15, 4.65, 0. ጨረስን። What about y grid data? መጀመሪያ 0.5, 0.8, 5, 1.945, 5.5, okay, ከዛ 1 ሜትር። ስለዚህ ሌላ ይቀራል ማለት ነው። አድ እንበለው 7 ነው የሚሆነው ማለት ነው። ይሄ 1 ሜትር ይሆናል ማለት ነው። ኦኬ ኦኬ አሁን ጨረስን። ኦኬ ብለን እንውጣ። ኦኬ ስለዚህ now next step የሚሆነው ምንድነው? let us define the material property. Go to define material, add new material, region የሚለው እኔ ከዩሮ ነው የምጠቀመው ዩሮፕ። let us define the concrete, C2530. okay, let us use the default values. okay, ባለበት default value እንጠቀም። okay okay, let us define the steel, add new material, Europe, material type steel, standard 1993. okay, EN European norm. okay, S 450. okay, let us use the default value of this material property. okay okay okay, now let us define the columns and beams. Go to define section property, frame sections. okay, here there are sections that are defined by defaults. So here we have concrete beam and concrete column. okay, let us modify this concrete beam. Go to modify and show property. You can also add new property. okay, for my case I'm going to modify this. okay, here change this into typical beam. okay, material C2530. okay, dimension depth 400, width 300. okay, so now let us modify the reinforcement. Modify show rebar. okay, make sure that the design type is beam. okay, cover to longitudinal rebar group centroid 41 according to the given data 41. okay, longitudinal bars change this into S450. for the confinement also 450. okay, now let us modify the property stiffness, which means stiffness. Here change this one into 0.5, 0.5, torsional constant 0.1, moment of inertia about 2 axis 0.5, 0.5 about 3 axis. okay, what I'm doing here is I'm considering the cracked section. okay, cracked section consider እያደረኩ ነው ምክንያቱም beam tension መሸከም ስለማይችል concrete beam bottom part ሁሌ ምንድነው የሚያደርገው ክራክ ያደርጋል ማለት ነው። therefore 50% የሚያክል cracked section ነው ያልኩ ነው። ስለዚህ 50% የሴክሽን ብቻ ነው የኮንክሪት ሴክሽን ነው ፓርቲሲፔት የሚያደርገው ማለት ነው። ይሄ ማለት ደግሞ ኦልሞስት ኮምፕሬሽን ዞን ያለው እየተጠቀምኩበት ነው እያልኩ ነው ያለሁት ማለት ነው። ኦኬ ይሄ ናምበር ግን ሁሌ 0.5 አይደለም። ኦኬ okay, now let us define the grid beam. okay, instead of adding a new property, let us modify the property of this typical beam. Okay, add copy of property. Okay, grid beam. Okay, dimension 300 by 200. Okay, ሌላው reinforcement እና property according to typical beam ነው የሚሆነው ማለት ነው። you can check it. Okay, እንደምታዩት እዚህ ጋር is 450 መቀየር መቻል አለበት። ኦኬ እዚህ ጋር modify show property ኦኬ እንደምታዩት ነው። ኦኬ now let us define the concrete column. Concrete column, you can add new property or you can modify this existing default section. Okay, therefore modify show property ገባለሁ እዚህ ጋር column እንለዋለሁ material C2530 dimension 400 by 400 sorry mm ነው ይሄ ኦኬ section shape concrete rectangular ነው ኦኬ reinforcement modify narc modify show rebar okay make sure that the design type is PM2 M3 design or column here እዚህ ጋር እንደዛ ብሎታል ማለት ነው ኦኬ therefore እዚህ ጋር clear cover for confinement እያለ ነው this is 25 okay 25 according to the given data here reinforcement is 450 are good is 450 okay so የሚቀረው ሌላ ነገር you can take it as default ምክንያቱም በኋላ ከዲዛይን በኋላ የሚስተካከል ስለሆነ ማለት ነው ኦኬ ራሱ area of steel calculate አድርጎ ስለሚሰጠን ማለት ነው okay now we have already completed defining the frame sections okay which means the typical beams grid beam and column okay now let us define the slab section go to define section properties slab sections here we have a default slab section let us modify it or you can add new property okay for me I'm going to modify this property modify just write slab material which means the concrete material C2530 modeling type shell tin we have other options shell thick membrane layered okay so for solid slabs with shell tin okay the difference between those modeling type I will make a video on this so here I'm not going to talk detail about it so the thickness of the slab is 150 mm according to the given data okay so type property type here you can use other drop stiff ribbed waffle but for our case we are going to use slab okay another here there is a modifier okay so currently default we can modify this one this stiffness must be modified okay so in this case like the beam and the column we are considering another the cracked section okay so this is 0.05 membrane in F11 direction membrane F22 direction membrane F12 direction bending M1 direction 0.05 this also 0.05 membrane M12 direction 0.05 okay the remaining will be as it is okay now we have completed defining all the sections which means the column beam as well as the slab okay next we are going to draw the column beam and slab let us start first by drawing the columns. Okay, ስለዚህ column ለመሳል first we have to change this into all story. Okay, this one here we have all story, similar story, therefore change this to all story. This means in one click we can draw a column in all story. Okay, therefore here in the drawing option we have different options to draw a column. Therefore you can use this draw beam, or you can use quick draw beams column, or you can use this quick draw. Okay, I'm going to use this one, quick draw columns in plan or 3D. Okay, ስለዚህ make sure that this one window is active in a plan view. Therefore this is in a plan view, roof line ያለው. Therefore let us select the column, quick draw. Here property option የሚል አለ። here column ነው ያመጣልኝ። maybe grid beam ሊሆን ይችላል፣ steel beam ሊሆን ይችላል፣ ትቀይሩታላችሁ ማለት ነው በምትስሉት መሰረት። therefore እኛ column ስለምንስል እዚህ ጋር make sure that this property option is column. Okay, now let us start drawing the column. therefore column ምን ላይ እንዳለ ይሄ architectural ጋር ሄዳችሁ ማወቅ ትችላላችሁ ማለት ነው። ቼክ እናድርገው። let us go to the architectural. እንደምታዩት እዚህ ጋር axis B ላይ እዚህ ጋር axis B4 ላይ አንድ ኮለም አለ፣ ከዛ D4 ላይ አንድ ኮለም አለ፣ ከዛ E እያለ እንግዲህ ሁሉም ኮለሞች አይታችሁ ቀስ በቀስ ሁሉን ድሮ ማድረግ አለብን ማለት ነው። ኦኬ now let us go to ETABS. ስለዚህ ምንድነው የምናደርገው? እዚህ ጋር ኮለም አለ as you can see here አንድ ክሊክ ስናደርግ ሙሉን እንሳለን። ኦኬ ኦል ስቶሪ ስላደረግነው ማለት ነው። ኦኬ ከዛ እዚህ ጋር አንድ ኮለም አለ። Okay, now we have completed drawing the column. ስለዚህ ይሄ ላጥፋው። ኦኬ ኔክስት ድሮ ማድረግ ያለብኝ ማን ነው? ቢም። ኦኬ ስለዚህ ቢም ድሮ ለማድረግ ቲፒካል ቢም እና ግሪድ ቢም ነው ያለኝ። ፈርስት let us draw beam in all stories. ኦኬ all story ላይ ባለበት ቢም ድሮ እናድርግና ከዛ ኔክስት የግሪድ ቢም ሴሌክት አድርገን ፕሮፐርቲው መቀየር እንችላለን ማለት ነው። ኦኬ ስለዚህ እዚች ጋር ትመጣላችሁ፣ ድሮ ቢም የምትለው ክሊክ፣ እዚች ጋር ስቲል ኮለም የሚል አለ ፕሮፐርቲ፣ change this steel column to typical beam. ኦኬ ስለዚህ እዚህ ጋር ቢም Now let us draw the solid slab. Okay, now let us draw the solid slab. Okay, to draw the slabs, you have here option draw floor, wall, draw rectangular floor, or quick draw. Okay, let us use quick draw first. Rectangular በሆነው እዚህ ጋር property d1 የሚል አለ. change this to slab. Okay, ራሳችን select አደረግነው. quickly we can draw slab. Now we have completed drawing the solid slab. Next, let us draw the cantilever slab. Okay, to draw the cantilever slab, we have to also draw the cantilever beam. Okay, okay, now let us draw the cantilever beams. Remember that the ground, the first, second, and third story, they are different. The first and second are typical, the third is different, the ground is different. Therefore, what we are going to do, let us draw in all story the cantilever beams, then we are going to edit, okay, like what we have done for the slabs and the beams. Okay, therefore let us here use quick draw beams. Okay, let us draw. Here we have cantilever beam, here we have cantilever, or let us see the architectural drawing. Okay, here if you see, this is the first and the second floor plan. Here we have cantilever, here we have cantilever, here we have cantilever, also here we have, okay, and here also we have cantilever. Here we have cantilever of 0.8 meter, and this is 1.3, and here we have 1.2. Therefore we are going to draw this, okay, in all story. Then next we are going to edit, because here እንደምታዩት ለምሳሌ እዚህ ጋር this is the first and second floor. Okay, in the third floor this part is not available here. Okay, we don't have any cantilever here, so we are going to delete it. First let us draw in all story. Okay, okay, now let us draw here. Okay, now let us draw the cantilever slab. Okay, okay, you can choose draw floor, you can use draw rectangular, you can use quick. Okay, let us use quick first. Make sure that the property is slab. Okay, now we have completed drawing all the slab, the beams, column, cantilever beam, cantilever slab. Okay, but now we have to edit. Okay, we have to edit according to their architectural plan. Okay, now let us go first to the plan mode, go to the base. Okay, here in the base we don't have any slab. Okay, therefore we have to delete. To delete this one, make sure that this is one story. Okay, if you make it all story, by one click or by one delete, you can delete all slabs or beams. Okay, therefore let us change this to one story. Okay, select. edit, delete. Okay. Ground floor. In the ground floor also we don't have any slab. Okay, delete. Edit, delete. Okay. Delete. Okay. What about first and second? Let us look to the architectural drawing. Okay. This is third floor. Let us see the first and second. First and second floor, there is a cantilever here, there is cantilever here. Between G and H, between H and I also there is cantilever. Here there is cantilever, here there is cantilever. Okay, so what about the third story? In the third story, the cantilever in GH and HI, they will be deleted. Okay, therefore let us go and delete them. Go to the third story and delete this cantilever. Delete. Okay, when you select members, you can see here. Okay, here you can read 2 shells, 8 edges selected. Okay, ምክንያቱም አንዳንዴ ሌላ ነገር ሰሌክት አድርጋችሁ ልታጠፉ ትችላላችሁ ሳታውቁት ማለት ነው። ዲሊት ስናደርግ በደንብ ኬርፉል አድርገን ሰሌክት ማድረግ አለብን። delete. Okay, sorry, we have deleted in the roof, but make sure that this plan view in the third floor. Okay, two shells, 8 edges selected. Edit, delete. Okay, what about roof plan? Roof plan slab የሚባል ነገር የለም. We don't have any slab. Okay, go to the roof, select, beam select እንዳታረጉ ቼክ አድርጉ። ኦኬ ኦኬ 21 shells 75 edges ምንም ቢም የሚባል ነገር ሰሌክት አላደረግንም። delete. ኦኬ delete. Okay, now finally we are going to edit the ground floor. Okay, go to plan, ground floor. Okay, let us compare this drawing with the architectural plan. Okay, this is the architectural plan. Okay, as we can see, this is the ground floor plan. Therefore clearly we can see in the ETABS we have cantilever beams here, but here in the ground floor we don't have. We have to delete this one. Next, here the beam length is extended up to 3.5 meter. Okay, therefore 3.5 meter by 1.945 grid beam should be drawn here. Another here we don't have any cantilever beams, and those should be deleted. Another here we have secondary beams that are extended in the 2 directions. Therefore we have to know this distance and this distance. Okay, this distance is, according to the architectural drawing, is 2.5, which means 5 divided by 2. Okay, this center. And this distance according to architectural drawing is 1.55, which means 1/3 of this, 4.65. Okay, now let us go and edit this in ETABS. Okay, now let us delete this. Make sure that this is one story. Delete this beam. Okay, now let us draw another beam, typical beam. Next, we are going to change to grid beam, okay, by selecting all members. For the time being, let us draw this. Okay, now let us select this and this, join, edit, go to edit frame, join frames. Okay, now this is one beam. Okay, next here we have to delete this cantilever. Okay, delete. Also we have to delete this one. Okay, now we have to draw the secondary beams here. Okay, first let us, the distance of this part is 1.5, which means 1/3 of 4.65. Let us divide this frame into 3. Okay, edit frame, divide into 3, apply. Okay, let us check. Okay, let us divide this into 2. Let us check. Yes, now we have create joint. Okay, now let us draw. Okay, now let us select the 2 members. Go to edit frame, divide, break at intersection with selected frame. Okay, let us delete these 2 members. Okay, now let us draw this beam. .5. Okay, now we have completed editing. Okay, now let us assign the grid beam. Okay, if you see this beam, it is typical beam. Okay, ስለዚህ ይሄ typical beam ነው። right click በማድረግ assignment ማየት ትችላላችሁ። section property typical beam ነው, but grid beam assign መደረግ አለበት። therefore select አድርጉት all member። ስለዚህ select አድርጋችሁ go to assign frame section property, grid beam, apply. Okay, Okay, go to assign, clear display assign. Okay, here we have 3 beams, 1, 2, 3. Okay, let us join them. Select arganal, go to edit, join frames. Okay, Lela, we have here also 2 beams. Let us join them. Edit, join. Here and natural. Okay. Now we have completed the modeling of the structure. Now let us assign the joints. Go to plan, base, select all joints, assign joint, restraints, fix it. Okay, apply. As you can see, the pin support, change it to fix it. Okay, now let us view the modeling. Okay, go to set display option, view by color of object, into section property, extrude frame, extrude shell, apply. Okay, let us close this window. Okay, as you can see, we have properly defined our section and we have modeled it correctly. Okay, okay, let us see this in a rendered view. Go to view, show rendered view. Okay, we can rotate and see everything. Okay, okay, here in the ground floor we have to draw a beam. Okay, here we have to one beam that we forgot to draw. Next, I think let us rotate this structure. Again, here we have 2 beams. Okay, that we have to draw. Okay, okay. Now let us go to plan, ground. Okay, go to draw beam, change this property from typical to grid beam because we are drawing a grid beam. Okay, okay. Now in this plan view we can see that this cantilever grid beam is its color is different from this. This means previously when we are selecting we missed selecting this member. Okay, let us check it. So this is typical beam. Let us select and change it to grid beam. Okay, select, 5 frames selected, assign frame, section property, grid beam. Now everything is okay. Go to assign, clear display assign, 3D, go to set display option, extrude frame, extrude shell, apply. Okay, now we can see that the structure has been modeled correctly. Okay, this is all about the tutorial for part 1. Next video will be part 2. Okay, In part 1, we have seen how to edit grid data, how to define material as well as sections for beam, column, slabs, and we have seen also how to model the whole structure, how to draw beam, column, how to draw slabs, and how to edit them for each story according to their architectural drawing. And we have also assigned support, which is fixed support at the base of the structure. Okay, the next tutorial will be part 2, which is we are gonna assign loads, we are going to define loads, we are going to define load combinations, we are going to assign rigid diaphragm for the structure, and also we are going to assign mesh for the slab. Okay, this is all about the part 1. The next video will be part 2. Thank you for watching.